Let's go over the next two problems, the word problems, very important problems. All right, so it says telephone company charges $4.95 per month for long distance phone calls plus 5 cents per minute. The monthly cost C can be described. So they already put it in an equation for you, but you should have, you guys know enough to that you would have been able to do that yourselves. Now it says, what is the y-intercept of the graph? Well, if you look at the graph, the cost is the y. So instead of C equals 0.05 m, you could think of that as y equals 0.05x plus 4.95. You didn't have to do it like that, but I mean, just so you know that they're having the cost as the y, and you can see that they have the time as the x. So it says find the y-intercept. Well, remember, the y-intercept is the point that it crosses the y-axis, and we always know that the x is always going to be 0. So I'm going to take my equation, and I'm just going to simply plug in a 0 in for x and solve. You end up getting 4.95. So the point would be 0, 4.95. That's the y-intercept. So I know 4.95 is about right there. That's where the graph is going to start. Then it says graph the equation. So we need more than that one point in order to graph it. So I can choose whatever domain I want. And I see down here, specifically, they use time of 40, time of 80, time of 120, time of 160. So that might be a good one to use. So I'm going to take my equation, and it's now instead of plugging in a 0, I'm going to go ahead and plug in a 40, because that would be the x that I want to know what the corresponding y would be. And when I do 40, I'm on my calculator right now, 40 times 0.05, 5 cents, and then I add 4.95, you get 6.95. Now, you didn't have to use that point, but I did because the 40 is there. So the point would be 40, 6.95. And I'm going to go ahead and plot that. Be about there. Now, at this point, you have 2 points, so you could go ahead and graph. But sometimes it's better to have 3. But with a straight line, I could go ahead and draw the graph. I can see that the cost is increasing as the time goes up. And the last thing it says, if you talk for 140 minutes. So they're actually giving you a specific domain, a specific x. So all I'm going to do is I'm going to take my equation and I'm going to plug in the 140 and find out what I get. So 0.05 times 140 is 7. 7 plus $4.95 is $11.95. So my point would be 140, 11.95. And I could actually graph that point too. 140 would be right here. And as you can see, 11.95. So what happened was, guys, I didn't do this incorrectly, but 11.95 is here. That should be on our graph. I basically did not use, because I didn't use a ruler, I didn't get a straight enough graph. So let me go ahead and plot my points again. 0, 4.95, it's right about there. And 46.95 would be about here. And again, that's why we use a ruler. And there is my line, and there are the answers. This would be my answer to the number 15, $11.95. Okay, next one. Killer whales usually swim at a rate of 33 2/10 to 9 7/10 kilometers per hour, although they can travel up to 48 4/10 kilometers per hour. Suppose a migrating killer whale swimming at an average rate of 4.5 kilometers per hour. The distance the whale has traveled in can be predicted by, so it gives us the equation. It says to graph it. Well, remember, if they're saying d equals 4.5t, I could think of that as y equals 4.5x. So the distance is the y, and the time is going to be the x-axis. And I'm going to go ahead and make my axis, and then we're going to go ahead and make a table. X, or the time, and then I'm going to multiply 4.5 times the time. And then that's going to get us y, or in this case, the distance. So I could pretty much use whatever x I want. I'm going to go ahead and say we're going to use x of, since you can't go negative time, we're going to use 0. I'll go 5 and then 10. So 4.5 times 0, you get a y of 0. 5 times 4.5, or 4.5, is 22 and a half. And 10 times 4.5 is 45. So I got to be able to graph anywhere from 0 to 45. So I'm going to go by maybe tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. You know what I can do is, let me make this a little bit smaller. And I'll go ahead and graph by 5s. 5, 10, 15, 20. Oh, you know what? I made a mistake. I thought that was the y-axis. So let me start over again. See, even I make mistakes. All right. So for time, we're going to go from 0 to 10. So this is the time. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 will be right there. For distance, I'm going to go between 0 and 45. So here I'm going to go by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Right? And then 45 would be up there. So let me go ahead and graph 0, 0. 5, 22 and a half. So 5 would be right here. 1, 2, 3, 4, 5. 22 and a half would be up past the 20. And last, 10, 45. So that'd be around here. And then 45 would be 10, 15, 20, 25, 30, 35, 40, 45, and 10. And then if you graph it, it should all form a straight line. And that would be the graph. And this is use the graph to predict the time it takes a killer whale to travel 30. So it says predict. So if it says predict, it means I don't want an exact answer. I just want to use the graph. So travel 30 kilometers would be the distance. 30 is right here. If I look over at right here, I can predict that it's going to take this much time. 1, 2, 3, 4, 5, 6, and 7. So I'm going to predict 7 seconds.